Hello everyone, welcome back to SAT Math Question of the Day. Today's Throwback Thursday, so when done, feel free to look at our Throwback Thursday question too. Okay, here's our question. Please read it, pause the video, come back, and let's do it. In the XY plane, the graph of the given equation is a circle. What's the area of the circle? Looks like you actually have to do some work to get the answer. I don't think you can go through each one and guess to see if that's the answer. I think it's like you have to actually go through this and what's known as completing the square. Maybe I'll do it quickly, and then for the people who just want to see the answer, then we can do it slower. You can write x minus 5 squared, and then there's 30. You add 25 to this side because you square that. And then you do y minus 3 squared, and you take a 9 and you add it here. We only care about the radius. So the radius of the circle squared is this. So we don't have a calculator on this, but you have a calculator on the digital SAT. So this is 30 plus 34. Well, that's good. That's a 64. But that's equal to r squared, so r is 8. So the area is pi r squared, or pi 64. Guess what? You could have just noticed.
5 times 64.
5 times 64. You could have noticed that we never really had to get the 8, because the area is pi r squared, and we know r squared is 64, so then you immediately know the answer is that.
Yeah.
I don't know if there's any other way to do this thing.
Yeah, I don't think so.
It's called.
Well, basically, you need to complete the square.
Yeah.
You need to complete the square twice. In other words, complete 2 squares, and that gives you the right hand side. There's the right-hand side that you need to know. The right-hand side, the constant. And that, once you find out this, you take this, t. T is equal to the square of the radius. And so you get the square root of t, square root of 64.
Yeah.
Square root of 64 is 8. And the area is pi times that. Actually, no, you don't have to take the square root.
I know.
Right? You don't have to take the square root. You don't have to take the square root because the right-hand side is r squared.
I know. Did you hear me say that earlier?
Right?
I said that earlier.
Did you say that?
Yes, I said that earlier. You're not listening.
Okay, good.
You're not paying attention.
So, yeah, cool. Like, you don't have to take the square root to find. Yeah. You know r squared, and therefore the area is pi r squared, and 64.
Right. So the key to this problem, we're into really getting into asking what's the essence of this question. What do they, when they wrote this question, what do they want to see if you know how to do? And you need to know something about the equation of a circle. What is the equation of a circle, and how does that relate to the radius? And also how to convert an equation of a circle that looks like this into what they call standard form, which is x minus h squared plus y minus k squared is r squared, where h and k are the center of the circle. Looks like they want you to know to do that. At least they did in October 2023.
Yeah.
And
so the key idea is the so-called standard form for the equation of a circle.
Yeah.
The standard form number 1 reads off the square of the radius.
Right.
And number 2, the standard form is found by completing the squares. Completing the squares of the x dependent terms, and completing the square of the y dependent terms of when the equation is given in an arbitrary form.
Right. So the problem really
or in multiplied out form.
So the problem really comes out to how do you complete the square? I did it very quickly. Um,
Well, no, two things. It's both. Two things. How to complete the square, and completing the square leads to canonical form, and canonical form gives you the square of the radius.
exactly, exactly, exactly,
Two
exactly.
things
So
that
we
need
already
it.
went over more than enough the second one. The problem is the
Uh,
mechanical completing of the square. I did it
mm,
very quickly. And very often people are really confused by completing the square. I mean, it doesn't help. It doesn't help that in school they say, well, let's write this as 10x squared x plus 25. Let's just say that, and then we make this x minus 5 squared, and then we add the 20, and then we do something. We subtract the 25. They force you to sort of write this first. I mean, you don't really need to. You don't really need to. You just know. You just know that
mm.
you cut that middle term. You cut the coefficient of the x term in half. You just cut this in half and go x minus 5
It
squared.
divided by 2.
Fine, divided by 2, cut it in half, divided by 2. This gives you x squared minus 10x plus 25. Oh no, you have an extra 25 hanging in when you write that. So you have a choice. You could subtract 25 here if you want. You could do that. Or you can add 25 to the other side. So it's nice to add. It's like a balance. It's like a seesaw. You add 25 to the other side. And then you do the same thing. You cut this thing in half, divide by 2. You go like that. And this adds in a plus 9 when you FOIL this thing out. So you just add a 9 to that side and you've completed the square. It's not that big of a deal. People make a bigger deal of it than it is. But you can either learn how to do it mechanically or sort of do it the way we did it, where there's some sort of understanding. So, yeah, completing the square. What is Seth doing? Cut 10 in half. Right, cut 10 in half. Right, yeah, that's cute. Okay, so today's Throwback Thursday. I guess we should move on. So first of all, introduce ourselves, I guess. I'm Joel. I have a PhD in mechanical engineering. We're my brother Seth. We're here to get a PhD in math from MIT, and I've been teaching computer science for a while at the SUNY Albany, now retired. And we're here to offer different approaches on how to do SAT math questions. That's right. We always ask the 3 key questions. What is the key? What are they asking in this question? Completing the square. Can the calculator help? Well, this was given back in the days when you couldn't use a calculator for 20 questions. This was not a calculator question, so the calculator doesn't really help. And what's the third question? Do you do this question differently from what you would do in school? Not really. Not really. Not really. Not really. Not really. Because you can't really guess and check the answers. Yeah, I guess that's it, right?
That's right.
Okay, so please dislike our videos. Please give us comments, and if you have any SAT math questions, email them to us at SAT Math Question of the Day. Now it's on to Throwback Thursday, where we go back to a test before 2016 when the SAT people gave questions that were more, I don't know about intelligence, but a little less involved, you would see fewer of these on a school test, as opposed to now where almost every question on the SAT comes directly from school. So, where are we? Here we are. This is our throwback question of the day. It comes from a practice book, an official practice book from about 25 years ago. It is marked hardest difficulty, difficulty of 5. Frankly, I'm not exactly sure why, and that's a little bit of a clue. And here, let's do it. And about this question almost feels like it can be asked in the modern SAT. One number is 3 times another number, and their sum is -10. What is the lesser of the 2 numbers? So, I mean, you could do this through 2 equations, 2 unknowns, but it occurred to me that it may be faster to actually use guess and check. I mean, if this is the lesser of the number, then the bigger one, I just realized you
Right, there's a problem. There's a problem.
This is negative.
Negative, yeah.
This is -9. This is, I don't know what that is.
Yeah.
This is -21.
So this is the number that is 3 times
5.5.
The other number is the lesser number when the other number is negative.
Oh, shoot.
All right, do it. We'll see what happens.
Wait. What number is, what is the lesser of the two? So you have to add, what number is 3 times another number? Right, yeah. So I think I'm doing okay. Because one number is 3 times the other number, right? So the lesser of the two of these guys. The lesser of the two are going to be these things. Aha. Wait, I'm so confused. Wait.
I think the most resilient method is to use algebra.
Yeah, I agree. Yeah, there's a problem here. So let x be a number, let y be the second number, and we're stuck with 2 equations, 2 unknowns. One number is 3 times the other number. So y is equal to 3x. And y is the second number, and their sum is -10. Fine, x plus y is -10. So it's not that bad. I'm not sure why this is a level 5 question. You just use substitution. You throw y in there, and you get x plus 3x is -10. 4x is equal to -10. X equals -2.5. Now, this number here, y, is 3 times that, so y is -7.5, so the answer is -7.5.
Yeah. I think using 2 equations and 2 unknowns enables you to do it without tripping your logic up with respect to negative numbers.
Yeah.
And figuring out ahead of time which of the numbers you're talking about is the lesser negative number.
You are absolutely right. And frankly, I don't think I would have done it. I was sort of like playing around here, guess and check, offering it as another possibility. But you're absolutely right, yeah. And I'm not exactly sure why they called this a 5.
Maybe because it tempts people to trip over themselves.
Yeah. I don't think this book tells you what percent of the people got it right, what percent of the people got it wrong.
And also, I wonder if 2 equations and 2 unknowns is one of the more advanced topics in the high school math up to then.
Right. Yeah. It is very confusing. Yeah, doing it this way, it was sort of like something just didn't work. So, yeah.
And so one key idea is that when negative numbers are compared, the lesser is the one with the bigger absolute value.
Right. Yeah, they purposely.
Yeah, so what are the rules? And then any negative number is less than any positive number.
Right.
And then comparing positive numbers, the lesser number is the number with the lesser absolute value. And in positive numbers, the number, each positive number is equal to its absolute value. For a negative number, the absolute value is formally the negative of the number, which is negative. The negative of a negative number is a positive number. Right.
Yeah, these pre-2016 SAT tests, there were more questions on the test that had a twist to them. This twist is that you have to know that the lesser of 2 negative numbers has the larger absolute value. There were more questions back then that had twists like these. There still are some questions that have twists like these, but there aren't as many as a percent of the test. So, yeah. So, okay. So it's always nice to see a blast from the past.
So
Which is lesser. Yeah, of course, the negative 7.5 is lesser.
this one,
So,
yeah.
it's not as critical.
And then if you have positive 7.5 and 2.5,
Yeah, which is lesser. The 2.5 is obviously lesser. Yeah, of course. Of course.
circle, circle, circle. Which one is it? Pick it up. Bingo.
Yeah, the 2.5 is lesser. Right. So, I guess the key. What are they asking you in this? What are they asking you to? So I guess two things. The big idea here. One, you have to know what the lesser of two numbers are, and two, it probably they're probably expecting you to know how to set up a two equation to a known word problem.
Okay,
And so,
should we talk about calculators?
no, I mean back then
Yeah.
there was no calculator allowed on the test at all, and I don't know if a calculator would really help you here.
Well, if you have the new, what's it called? What's the calculator they
Oh,
give you for the
Desmos,
essay?
Desmos.
That's the Desmos calculator. You could type in the equations
Right. Yes, you could.
and
Yes,
observe,
right.
and
Yeah.
it plots them
That's
and then
right.
tells you the solution.
That's right. Yes, if you have a system of equations now on the really modern digital SAT, which just started in the winter of 2024 in the United States.
Mm,
Yeah, if you have a system of equations, that's true. You're right, Seth. You have a system of equations
yeah,
now. You type it into Desmos, and you see where the lines cross, and that's the solution for X and Y, and then you have to figure out which one is the lesser of the two. Right. Yeah. But at
yeah.
the answer, what
Well,
you're going to see that the lines would cross. In fact, we can even do a rough graph of these, can't we?
yeah.
So we could just finish off with that. We could just do a rough graph.
I've one. After you finish this, I have another
Y is equal to
observation.
3x is pretty steep. This is y is equal to 3x. And now we have y is equal to negative x minus 10. So we're down here. And we'd say, yeah, it's a negative slope of a normal, like a 45-degree line. So that would be the answer. And we see that is the answer. It's negative 2.5. In perspective, it looks right. Negative 2.5, negative 7.5. So the answer would be the lower one, which would be the y
Good.
value.
All right, now let me comment on what this graph tells me. Very interesting.
Yep.
The one number is 3 times another number.
Yep.
Is expressed by this line. Now, when you see the line, it reminds you that of the two numbers, they either must both be positive or they must both be negative.
Right. There's the line.
Yeah. So one case is that the two numbers correspond to a point that's in the first quadrant.
Right.
And in that case, they are both positive.
True.
The other case is that they are both negative.
Right.
And then there's the boundary case where they're both zero.
Right.
So one might solve this problem by realizing that in this problem we have two numbers that are either both negative or both positive.
Right. Yeah.
Then they tell you their sum is minus 10.
Right.
That means they must both be negative.
Right. Right.
Right?
Yeah. Well, also
and then you look at the answers for clues.
Yeah.
And observe that the only two numbers among the answers whose sum is minus 10 are this one and this one.
Okay.
And of these, the answers give you some great choices for guessing and checking.
Right.
You
Right.
notice that the two numbers are therefore A and E, and then the question is, what is the lesser of them? Well, you have to catch that the lesser of two negative numbers is the more negative one,
Right.
and so you pick the answer E.
So that's very absurd. You're right, Seth. Using test-taking logic, if one of the answers is A, then it's sort of complement, its thing that adds to -10, would also be a choice, because that way someone would make a mistake, so they would have to put both in. But also notice that these two also add to -10.
Oh, they do?
Yeah, 3 and -7.
Oh, ouch.
But
they do. Yeah,
but they are
okay, I
not
didn't notice that.
times each other. They are not 3 times each other.
Yeah, okay, yeah, that's right. Yeah,
So,
I missed that. Okay.
Yeah.
Oh, yeah,
That's
yeah.
a really smart observation. The
Yeah.
question is,
And
is
I
that,
didn't notice it.
no, we didn't notice it either. But the question is, it's probably faster just to solve the problem this way than to sit there and realize that and spend the time thinking about that and then realizing it. But we realize it afterwards. But yes,
Yeah, I think the way we is the most reliable.
Yeah. The way we did it is "quote unquote" the right way of doing it. Yeah. Okay, so I think we've wrung enough out of this one, and I think we're done. We're done with Throwback Thursday for this week, and hopefully we'll be back tomorrow and Friday to close the week. Okay,
should we give our introduction?
Oh no, we did that.
Oh, we did. Oh, yeah, okay.
Not paying attention.
No.
Yeah, a lapse of attention today in the beginning. No, we did that. Yeah. We did that in between, just in case people were not interested in Throwback Thursday. Yeah, we did that. Okay, everyone. Okay. So have a great day. We'll see you.
Okay.
Hope to see you tomorrow.